choose one person.
Hello guys, good evening. How are you?
Broken and they will be same as the linear. Okay.
Good evening, guys.
So that means if 6 people want to sit in a circular table, then for the first person we have only one choice because all the chairs are identical.
Good evening, guys. How are you? So welcome to the IOQM session. I hope everything can hear me properly, clearly, very clearly. Can you?
Because now the chair can be considered as in a
Yep. So let's start. Hi. Hi, very good evening. So as you know, we'll be doing problems. Hi. I have one token. Hi. Are you from Mexico? I guess that's most probably. Alvin token.
Okay. For a circular this is the.
I hope you're in Mexican.
Now I'll give you a problem where
Right.
you have to use the idea of
We are getting a lot of background sound. I wish I could do that. Just give me a minute.
And this circle
Just give me a minute.
Can you just hear me properly now? Any background noises? Any background noise? Now. Is it possible?
No, you have 6 different parts.
Yeah. Perfect. No background. Very good. Yeah. So welcome back, and we'll be doing problems as you know. The problems are in front of you. Let's start. Let's start the class. Very good. Let's do it. Just share the link with these people. Okay. So the problems are in front of you already, so you can sort of use that to your advantage. And in the meantime, I'll share the link with the people who will join, and that's it. So give me one moment. Give me one moment. Okay, so that's it. So let's start. Yep. So yeah, hi, Alpen Koken. Let's do the first problem. For each positive integer n, Sn is the sum of the digits of n. Okay, and the question therefore revolves around the fact that for how many values of n, n plus Sn plus S of Sn is 2007. So I hope you understood the definition. This Sn is the number of Sn is the sum of the digits of n. So the question is for how many values of n plus Sn plus S of Sn is equal to 2007. Okay, so let's do it. Let's zoom in thing. So it's a problem, guys. I think it's a little bit so in a bit. Oh, sorry. Yes, so that's the problem. Okay, so guys, focus on the problem. So for any given positive integer, Sn is denotes the sum of the digits, and for how many values of n plus Sn plus S of Sn is equal to 2007. So how will you approach this problem, guys? What do you think? How will you approach this problem? That's the question to you. How will you approach this problem? Okay, I hope you understood what the problem is all about. Yeah, that's a very good thing that n is congruent to 7 mod 9. So what is essentially n is? Perfect, very good. You're totally correct. N is congruent to, yes. Or is it? Hi Sauradev, good evening all of you. N is congruent to 2007 modulo. I didn't get this point. Why is this true, guys? N is divisible by 9. Why is this true? Can someone tell me? Why this is true? Which is congruent to 0 mod 9? Which is congruent to 0 mod 9? Which is congruent to 0 mod 9? That's the question. Yep. Which is the problem 0.9. Yeah, so one thing you can do, I mean, okay, I'm waiting for your ideas. Let's see. Very good, Raghav. Very good. Very good. I like this idea. 3n is congruent to 2007 mod 9. Perfect. Very good. So what do we get from here? Why is this true? Let's try to understand this very carefully. Let's take this one. So what do you have? We have the following result. So what is that? N minus Sn is divisible by 9. N by Sn divisible. So we lovingly write it as n divides. This is a symbol of divides of n minus Sn. Okay. Sounds good. So now how will we like sort of approach this problem in this aspect? So we'll show that our aim is to show the following, that 3 must divide n. That's the idea. 3 must divide n. Why this is true? Observe the following, that observe this very carefully. The main idea, essential line. Yeah, my voice is cracking. Is it all for all? Yeah, 3 divides n, which is actually what it means. Okay, so it means the following, that observe that n and Sn gives the same remainder with when divided by 9. Okay, n and Sn, since n minus Sn is divisible by 9, so therefore we will show that 3n minus n minus Sn plus Sn plus s of Sn, that is the actual number, is actually divisible by 9. Okay, we'll show this. Okay, that means what? That means that means this. Yeah, that means the following. That means 3 divides. Why this is true? Because if you just add it up, you see it will be 2n minus Sn minus s of Sn. Okay, you will get this one. Sure, right? So how do you write it now? You write it in a very simple manner. You write it as this. Now this is same as twice n minus Sn plus s of n minus s of n. Right? Now 9 divides n minus s of n. Replaces n by s of n. So 9 also divides s of n minus s of n. Right? So therefore what happens? 9 divides this and 9 divides this. Therefore what do we get over here? We get the following. We get that 9 divides thrice n minus 2007. You see? 9 divides thrice n minus 2007. What does it imply? 3 divides 9 minus something, right? 6206279 669. Okay, perfect. So this implies what? That means 3 divides 9, right? 3 divides n. So we get. So all of you understood this result, guys? How did it come? We don't need such, but I am just seeing. Oh, 3n. We just assumed it. We will prove this, that actually it is true. 3n minus this. Okay, we'll show that this. So now we have seen that 3n minus this is 2n minus this. Now we divide this 2 into n minus Sn plus Sn minus s of Sn. Okay, so that means that n divides this and n divides this. Therefore n divides this sum. Therefore I'm not n. 9 divides this sum, and therefore 9 divides 3n minus this sum. This is 2007 from the problem, right? Therefore 9 divides 3n minus 2007. Therefore if you divide by 3, you will get 3 divides n minus 669. Now this is divisible by 3 again, so therefore 3 must divide n. Okay, it's easy. right? So all of you understood it, guys? So we got n divides 3 divides n, but that doesn't is not going to help because all 3n ke liye it will not happen. Okay, so it's an extra information. 3 divides n. So let's try to find out what is the thing now. S of n plus s of n is what? Is equal to 2007. Okay, which 2007, you know, it's for example, if you take, so what is the, so you understand, for 3 is equal to 3, n equal to 3, it will not happen. So the idea is that n must have a lower bound and n must have an upper bound. So it's an inequality method in number theory. Okay? It's very important to understand. This is very important in number theory. Okay, this idea, so inequality idea. So observe, can you tell me a good upper bound for n at this moment? You can do it in Shubham. You can do it in the number theory by Niven Jukaman. It's a very good book. Okay, so what's the upper bound for n? That's very good. You're right, Sarthak Dhobale. Upper bound is very good. Upper bound is 2009. 2007 actually. N is less than equal to 2007. Must be, right? N can be more than that. That's a very vague upper bound. The better upper bound is possible. So we are just trying to. So essentially, we'll find a very loose upper bound, and then we will try to generalize that to. I mean, not generalize, but make it shorter and shorter and shorter, so that it's perfect. Okay, so what's a good lower bound? I should add the word intelligent. Okay, that should make sense, I guess. I should add the word intelligent. Intelligent lower bound. So what is the lower bound for n? What do you think? 1000 will work, 1000 will not work, right? So we'll, acha, the idea is this. We'll for the questions you should ask is this. N is how many? N can be how many digits? N can be how many digits? Can n be 3-digit number? No. When it's 3-digit number, maximum it can be 999, and the whole sum can be maximum 1000 and something. So n must be 4-digit number. Try to understand this very carefully. N must be a 4-digit number, but it cannot be a less than. So it must be 4-digit number. You need to understand this. So therefore, n must be greater than equal to 1000. Did you understand this, guys? It must be a 4-digit number. Must be 4-digit. So we sort of trying to. So essentially, the idea is that find an upper bound. Find. That's the idea. How we were finding out? See, by logical steps. Now we need to reduce the upper bound, right? So now let's reduce the upper bound. Observe the n must be divisible by 3. So it's an extra condition. So observe that this upper bound will not work. Okay, so there are better upper bounds. What are the better upper bounds that is possible? Can someone give an idea on better upper bounds? Yeah. Oh, so tell me that why it has to be that lower bound. Shubham Mal. Why it has to be the lower bound? What do you think? Let's try to think about it. Why, how it can be true? Okay, okay. Why 4-digit? Because butting star, because if you take 3-digit, the maximum 3-digit is possible with the sum. Okay, if you want to maximize the sum, it is possible is for 999, right? But if you do 999, it will get, you will not get 2007, much less than 2007. So n cannot be less or greater than, n cannot be a 3-digit number. That's my idea. Because the maximum 3-digit number whose sum is also maximum is 999. Perfect. So that's the idea. So try to understand. So to understand 2000. If you take n equal to 2000, let's try to do some like experiments. Then s of n is what? 2, right? And s of n is 2. So n plus s of sn plus s of n is equal to 2004. Okay, but it is not the maximum, it's a sort of a minimum value possible. So n can, what is the maximum value in what is the minimum value that can in minimum largest value sort of idea? That is 1999, right? 1999, right, guys? Yes, perfect. So it's also not divisible, but I'm trying to find the lower bound. We are not sort of injecting the idea of divisibility by 3 here. So we're sort of taking the lower bound. Okay. We're sort of taking the lower bound. Okay, so what's it? So we are sort of trying to understand this very carefully. Try to focus it very focused. Okay. So n equal to 199. So in that case, Sn must be the largest, right? So n cannot be on the opposite. The n must be less than equal to 2007. And let's say n equal to 1999. In that case, what is possible? In that case, observe the S of n is what? S of n is on 27, 28. Okay, and S of n is 10. So what we are getting, n plus s of n is n plus s of n plus s of n, we are getting it's 2019 wait 2009 plus 20, that's 2037. Okay, which is not going to work because sum is going to 0.7, right? That's it. So therefore what do we do? N must be less than equal to this, some sort of not less than equal to, n must be less than equal to this, of course, right? So we can sort of try out all the numbers from 2000 and 2007, so divisible by 3. So that is 2001. Let's write it out. 2001, 2004. These are the only two possibilities, right? So let's check it for 2001. Or what we get? For 2001, we get 2001 plus 3 plus 3. Perfect. So we get the 2007. 2001 is one of those numbers. So 2004, we are not getting it. Okay, so we get for more greater than equal to 2000, we get what? We get 2001 is one of the solutions. So therefore, sort of we are reduced to this. N must be less than equal to 1999. Okay, and plus n equal to 2001. So we are sort of reducing the uppercase. Okay, 2001 is solution. You're right, totally right. So what are the possible things that we can do now? Okay, so if you try to understand that which is the minimum possible bound, you can sort of do it like this. So let's take this number. So 19 must be there. So let's take some a b. Okay, if you do this, then what do we get? Plus a plus b plus 10. Okay, plus sort of, I mean, sort of we can assume that a plus b is more than 10 or less than 10. Okay, it depends upon that. That's the essential idea. So if you do this, let's try to assume this 195 and you get here. So it's sort of 19 a plus 1b. So you can sort of do this, right? So let's try to check it out. So let's check it for 1989. What happens for 1989? Also, it sort of will not happen in our way out. Okay, so we are sort of doing like this. We are sort of checking like this. For which year it's actually going to happen? Okay, so if you are doing for 7, observe if you do it for 7, what is happening? If we do it for 7, it's happening to be 8 plus 9, 17 plus 9, 26. So it's plus 26 plus 8. So what is happening? 1927 1979 plus 26 is what? It's 2005 plus 8, which is not happening. 2013 is running out. So therefore it must be at least greater than equal to 69. Okay, 1969. That's the idea. Okay, 1969. It should be that greater than equal to. Therefore we sort of reduced it down to 1969 lower bound. All of you understood how I made this lower bound much more stricter? All of you understood this? Sure, you can share, but we will do it in a different manner. Okay, let's check. So we'll do it in a different manner. So sort of we are trying to reduce the solutions down. Okay, now what do we do? I know how we are going to do, Kanishk, so I will not like that kind of much more less intuitive, what you're going to say. You are going to say multiple of 196, you're going to say multiple of 169, 197, like that. I know that you will tell that. So, but here we're going to do it by hand experiments. Okay, so we got of 1969 we got, and we got 1999. Okay, so less than 1999. So we can sort of check out now for which it happens. So write down all the numbers divisible by 3. 1969 के ऊपर it should be 1971, then 1974, then 1977, then 1980, then 1983, then 1986 plus 1989, 1992, and 1995, and 1998. So we have these 10 opportunities out here. Now let's check one by one for which it happens. Okay, that's the idea. So if you just check it, you see that for this, it's sort of just check it out, and you will find out that it's happening. It's happening for 1977, I guess. 1980, I guess. Okay. 1983, I guess. And 2001 is already here. Okay. So it will be happening for this 4 cases. Okay. The rest will not work. Okay. That's just very simple idea. Okay. Very simple and very elegant. I'm doing so much casework because it makes sense. There are a lot of. I'm not doing casework. Okay. I'm just computing by doing hit and trial method. So what is my algorithm here? My algorithm is the following: that we first shown that n 3 must divide n. That was sort of the reduction point, and we then showed that n plus s of n plus s of n, if it's 2007, then n must be less than or equal to 199 and greater than or equal to 1969. Okay, apart from n equal to 2001. If this happens, then we list down all the 10 multiples of 3 which are between this interval and check it. That's it. Okay, it's very simple to check actually. Just do the following sum. That's it. I mean, you can understand from the first step actually what is going to happen. So you can sort of check it from here. So this is sort of called hit and trial and example method. Okay, that's it. So if you try to come up with the actual solution which is there in the net or whatever, then it's sort of not kind of, it's not intuitive in that sense. Okay, that's why I did it in a different manner. All of you understood it? It is not. It is possible with casework. Okay, but I will not show the. I will not. As you know, I don't like to do it by normal methods. There are also other methods for you to explore. Okay, that's why I showed like this. Casework is a bit much more less intuitive, that and less intuitive, that I know you know. Okay, that's the idea. Okay, all of you understood this, guys? Any doubts from your end? Very good, very good. Okay. Sure, I will give it next time, Raghav. I'm so sorry for that. So actually, this is like it will take time, so I have to sit idle for 5 minutes, which is something that I don't like to do. But yeah, I will try it for at least 2-3 minutes. And yeah, I will tell you why it's 1969. It's 1969 for the following reason, guys. So first of all, we understood that it must be 190. It must be 1000, right? And then we moved to 1969. Okay. So why 1969? Because before 2000 it will be of the form 1 and some a b c, right? So we are sort of trying to see the lower bound. Okay, so we are trying to see that for which numbers it's not gonna work. If it doesn't work for something like, okay, I should do it in a different, I should tell you in a different manner, I guess. And why 1969? Yes. So 1 second, give me a moment. So what will happen before 1969? Why it will not happen? Before 1969, every number is less than, I mean, what is the largest number that can be maximized? The sum can be maximized. So we are trying to maximize the sum, right? So before 1969. Is there a number which can maximize the sum before 1969? No, because it contains all the possible largest value, no? 1, 9, and 6. 1, 9, and 9. The 6 is only variable. And if you decrease the 6, I mean, on other numbers, essentially it will be like decreasing, right? So if you decrease the 1969, if you take any number less than 1969, the sum will be less than the sum of 1969. But the sum of 1969, and essentially for the expression of 1969 ke liye, for n equal to 1969, the expression is less than 2007. So therefore, for any number less than 1969, the expression must be less than 2007. Therefore, it must be greater than that. All of you understood this, guys? Okay, sure. I will explain it in a much more interesting way. Try to understand this. For any number 2-digit and less than 2007, the first digit must be 1. The second digit can be at max 1. The last digit can be at max 1. Okay, a 9. We are sort of playing with the middle digit. We have seen that if it's 1998, it cannot happen. So we are sort of trying to find an A such that the sum is less than. So if you take any number n less than 19A9, okay, observe that S of n must be less than S of 19A9. Okay, why? Because 1, 9, and A are the largest. Okay, so any number less than this must be less than individually in the digits. So therefore, S of n must be also less than that. Okay, that's the idea. And it doesn't matter actually in that case. So therefore, if n is less than 19A9, okay, then S of n must be less than that. So now let's try to take A is equal to 6 and let's see 1969. If you do 1969, S of n will be what? S of n will be 9 plus 9, 18 plus 1, 19 plus 25, okay? And S of n will be what? 7. So what will be the sum? The sum will be 32 plus 1969. That is what? That is 2001, right? Now if you do 1979, it will be more than that. So that will not kind of work, you know? That is not gonna work. It will be plus 8 and plus a lot of stuff. So therefore it's not gonna work. So therefore 1969 is the optimum because all numbers less than that must be less than 2007. So it's like sort of 205, 25. So if it will be never be 2007, okay, for all numbers less than 1969. Never be. So therefore lower bound must be 1969. All of you understood it? Now, we are sort of taking A to be sort of varied from the upper 9. We see this for 9 it will not work. We saw that for 8 it can work. Okay, for 8 it can work actually, you know. And then we move on to 7 and we saw that for 7 it can work. It is more than 2007. So for 6 we saw that it is not 2007, less than 2007. Therefore all number less than 2007, I mean 1969 sort of will lead to lesser that n plus s plus s of sn number. Okay, that's the idea. All of you understanding this, guys? Therefore n must be greater than or equal to 1969. All of you understood that? Any doubts from your end, guys? Do you have any doubts from your end? Very good, very good. Okay, so let's move ahead to the last problem of today. I think you will not get time to do more. We are progressing. That's good actually. We are sort of taking time. So you can sort of generalize this problem, you know, sort of generalize this problem more and more and more by including more an s of n. Okay, you can sort of generalize this problem. So you can include as of n possible. Okay, as many s of n possible. So n is n plus s of n plus s of n plus m times of s of n is equal to any number. Okay, how will you solve this problem? What is general algorithm? Essentially, the algorithm is essentially like this. You can sort of understand from here that it depends on depending upon the n value, the m value. We can sort of understand that m. So first step is that 9 divides mn. Okay, it should must show that. Sorry, m plus 1n. Okay, and therefore you can sort of understand that m equal 2 clear different, m equal 3 clear different. You can sort of tell that and 9 must divide n. Okay, so that's the idea. Anyway, so it's a big problem. You can do it a research problem, guys. Okay, and send it to me. It's type. Okay, so sort of we can do it forever and see sort of when it's happening. Okay, that's the idea. But you know, like there's this catch over here. If you take n equal to 1, and if you take m equal to 2007, gonna walk actually. 2006, it's gonna walk. So restriction on m is sort of much more challenging problem. But if you can write an algorithm generally for solving this problem without using an entire for loop, then it's fine. So that's the idea by using a bit of mathematics. Okay, let's do this second combinatorics problem. So let's call a set of integers Spacey if it's contain not more than one out of any three consecutive integers. How many subsets of 1, 2, 3, or 12, including the empty set, are spacing? Spacing. Call a set of integers Spacey if it contains no more than one out of any three consecutive integers. I hope you understood this. Contains no more than one out of the any three consecutive integers. Okay. So take any three consecutive integers. It must contain at most one. Okay, no, not none of them. That's it. So if you take a chunk of three consecutive integers, then it must contain at least one, at most one. Okay, that's it. So how many such empty sets? How many subsets of this are spacing? Okay, let's take an example. For example, one. So for 1, 2, 3, it's you're taking. Okay, 2, 3 we cannot have 2, 3. So 1, 2, 3 it's done, right? So we cannot take 2 or 3 more. So we can take 4. Okay, 4. If you take 4, then we cannot take 4, 5, 6. So therefore it's 7. So this is sort of a Spacey integer set. You understand? 159, yeah, 159. So you can do that. So I will that's requested by Raghav. I will give you 2 to 5 minutes to think about this problem. You're not understanding, guys? What you're not understanding? Tell me. What you're not understanding? Budding stars. So it's a number is called Spacey. If you take any any group, any cubicle of three consecutive integers, the set must contain at least at most one of them. Okay. That's the idea, buddings. If I would have put 2 over here, observe that among 2, 1, 2, 3, 1 and 2 both are there, but we want at most 1. So that's it. All of you understand the problem, guys? Any doubts from your end? Recurrence really seems the best shot, maybe. Let's try to find it out. Okay. The question is that call a set of integers Spacey, okay? Because there's a lot of space in between. If it contains no more than one out of any three consecutive integers, okay? That means if you take any three consecutive integers and you take a set, which is a Spacey set, then if you take any chunk of three consecutive integers and compare it, only one, at most one of them among them must be there inside, not less, not more. Okay, that's the idea. Okay, guys. So think about this problem. Think about this problem. Oh, nice. I like the way of approach, Raghav. Reconciliation is better for this problem. Yeah. Alper and Koken is excited now for this problem. It's a bit harder on his side, I guess. I mean, he's enjoying, I guess. So we call a set of integers Spacey if it contains no more than one out of any. So yeah, so if it's an there's an n minus one length and out of this n, perfect. I think reconciliation is very good over here. So tell me how you do it. That's a very good thing, you know. I like the way of approach of this problem. How you did it actually. That works, right? That's a very good way it works. Okay, but without recurrence, so we will do in two ways. Okay, one with reconciliation and one without reconciliation. Okay. Very good. I like the way of this approach. Okay, so let's do this in this reconciliation, guys. So it's a very good idea of example of reconciliation, guys. Let's try to understand this very carefully. So s of n equal to s of n minus 1 plus s of n minus 2. Very good, yeah. So what is n? Sn is equal to, observe that you take a Spacey subset of 1 to the power n minus 1, okay? And consider Spacey subset of this, okay? And if you add n, if it contains still n minus 1, it will not work. So there can be two cases, okay? Sn can be what? Understand this carefully. Sn consider. So there can be two cases, okay? Try to understand very, very carefully. 1, 2, 3, dot, 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 n minus 2, n minus 1, n, okay? But understand very carefully. So among this, there are three cases, actually two cases, okay? When n is there, and n is not there. See, if n is there, then what will happen? If n is there, n minus 2 and n minus 1 will never be there, right? If n is there, n minus 1 and n minus 2 is never be there. So it will be what? It will be s of n minus 3, right? Did you get this point? It will be s of n minus 3, right? Any Spacey set of this plus take any of this one, plus take n. Okay. Now suppose n is not there. Then naturally it will be s of n minus 1, right? So what do we get? We get that it's s of n is equal to s of n minus 1 plus s of n minus 3. Did you get it, guys? Was the reconciliation true as you have told? I think there was some issues over there. So there are two cases, okay? N is there and n is not there. If n is not there, then you delete n and it will start from n minus 1, right? And if n is there, then it cannot happen n minus 2 and n minus 1. It must happen till n minus 3. So if you add just n to it, that's it. Simple stuff. Simple, beautiful stuff. So you get what? S of n equal to s of n minus 1 plus s of n minus 3. That's it. Very beautiful, right? Guys? That's the beauty, okay? So therefore you get what? S of n equal to s of n minus 1 plus s of n minus 3. So what you get over here, you can solve this reconciliation out here. but it will be a bit hard for you to do this. That's the idea. It will be a bit hard for you to understand how to do this actually. It's a bit hard actually. It's kind of hard, yeah. Yes. So yeah, it's really a bit. Can I explain this to you? Just give me a moment. S of n minus 1 is sort of S of n minus 2 plus S of n minus 4. Okay, so this is a recurrence relation you get. Okay, that's a very good idea. Now, if you know how to solve it by characteristic equation generating function, then it's totally fine. Okay, then it's very good. You can really solve it out. Okay, if you know how to solve it by general, like if you know how to solve Fibonacci equation by characteristic equation, it's just a bit hi-fi stuff. I am not doing this, but let me tell you a bit. One second. Shoot. One second, my pen fell down. Thank you. Yes. So the idea is the following, it's this 1 x cube. Yes. So it's a root of this 1 minus x cube minus x minus 1. Iska root will be the actually sort of what should I tell you? Yeah, so the coefficient of x. Yes, you're right. So if you just do this 1 by 1 minus x cube, and you find out the nth term of this polynomial, nth coefficient. Nth coefficient is this Sn, okay? So sort of by generating function you can do it. I'm not going to that, okay? I'm not really going to that. We can really find the value. We can really find the value, but what is required over here? What is the question? Find the value of S of, yeah, that's very true, that's so good. That's so good. We can do this by this manner. I like this method, okay? So you can do it this like, so S of, let's try to find S of 1. What is S of 1? S of 1 is 0, right? There's no, S of 1 is 1, sorry. S of 2 is also 1, also exactly 2. Oh, I'm so sorry. It's 2, including the unit, including the what? Empty subspace, okay? It's 2. 1 and 5. It's 1, 2, and 5. 3. And S of 4 is what? S of 3 is what? S of 3 is 1, 2, 3 is there. 1, 2, 3, and 5. 4. Exactly 4. So therefore you can find out S of 3 over S of 3, S of 4 over S of 4 is what? S of 3 plus S of 1. That is 6. S of 5 is what? S of 4 plus S of 2. That is 9. S of 6 is what? S of 5 plus S of 3, that is 13. S of 7 is what? S of 7 is 13 plus 19. Okay. S of 8 is what? S of 8 is 7, 19 plus 5, 28. Okay. And S of 9 will be what? 28 plus 6, that is 41. S of 10 will be what? 41 plus 19, that is 60. S of 12 will be what? S of 11. S of 11 was 60 plus 8, that is it's sort of 28, I guess, yes. 28 plus, that is 88. S of 12 will be what? S of 12 will be 88 plus 9, that is 129. So 129 is the answer, I guess. Yes, 129 is the perfect answer. Perfect. Very good solution, guys. I like this solution. Okay, 1 to 9. But you know, there's a way of doing it. So I will sort of, you can take this as a combinatorial argument problem. The following I'm going to give. So we can do it by direct counting. Okay, let's do it like this. We can show how two simulated things can be done like this. So this is way, this is try to compare that how this two comes up. So therefore, number of Spacey subsets is 6 choose 4 plus 8 choose 3 plus 10 choose. So general term will be what? General term, let's see. General term will be actually, try to understand this what's happening. 6 choose 4, 8 choose 3, 10 choose 2, 12 choose 1, and 4 choose 0. So how it's really happening? 14 choose 0. Sort of going from 6, 8, 10 to 12, the even numbers. Why the even numbers? Any stuff, any beautiful stuff out of here, okay? So that's the thing we are gonna explore over here, okay? So from 4 to 1, how is this 4 coming up? Why 4? Okay, so let's try to understand this. So let's try to understand this in a combinatorial aspect. We have done this in a normal aspect by reconciliation, which is really good. Now let's take some choose and permutation. Okay, that's the beauty of it. So we'll do it in two different ways. That's the beauty of this problem. Okay, guys, we'll do it in exactly two different ways. Okay, so do you want to think about it for more time? Kanish, you. Anyways, Kanish. Kanish knows all this stuff. I don't know how. Anyways, and he knows the exact solution on net. So we'll do it in a different way. Okay. Let's see. So how will we approach this problem in a much more interesting aspect? It's a very easy that among three consecutive numbers, no three consecutive numbers will be there. That's the idea, okay? No three consecutive numbers will be there. That's a very good idea. That's the only idea actually. Okay, this is the idea, beautiful idea, okay? This is a beautiful idea. Let's try to understand this. Suppose let's check this. x1, x2, dot xn, okay? This is the idea. Okay? These are the numbers that we have selected. The Spacey subsets ka number, okay? xk. Let's say we are selecting a k subset, Spacey subset. So k Spacey subset. So let's see the k Spacey subset, the k elements with Spacey subset. So observe that this is gonna be true. If x1 is the minimum, so observe that if x1 is the minimum, so let's try to fill this. So let's not take this. So let's take x1 is the minimum, okay, among this. x1 is the minimum among all this. x1 is the minimum among all this, then what will happen? The next number cannot be, so observe this is x1, then x1 plus 1, then x1 plus 2. Okay, so the next number must be x1, at least the next number x2 must be greater than equal to x1 plus 3, right? So understanding this? So therefore, if we take any random subset, if you take any random subset that is not Spacey, any random subset, okay? Observe this very carefully. x1, x2, x3 dot x less than xk. How we can make it Spacey? We did x1 and then we take x2 plus what? 2. Okay. Also the x1 and x2 plus 2, whatever number you take, will never be between this three consecutive range. Okay. Let's say x1 equal to 1. No, it should be x1 plus x3, x2 plus 3, I guess. Yes. Also, if you take x1 equal to 1, okay, no. I'm so sorry. x2 is greater than 1. So if you take x1 equal to 1 and x2 is equal to 2, also this is not a this is a Spacey subset. Okay. Therefore, next one will be x3 plus 2 plus 4. Then x4 plus 6. Karte xk plus what? 2k minus 1. Did you understand this? Did you understand this? Right? So therefore, what is happening over here, guys? So therefore, this must be less than n, right? Less than equal to n. This must be greater than equal to 1. xk plus 2k minus 1 must be less than equal to n. Therefore, xk must be what? Less than equal to n minus 2k minus plus 2, okay? Right? Therefore, what is happening? What is beautiful about happening? So therefore, it's sort of, you can get a bijection between this set, a Spacey subset, and a set we are choosing out of elements where the number of elements is less than equal to, where the element will be less than equal to n minus 2k plus 2, okay? That's the idea. So essentially, what is boiling down to this is that choosing a k Spacey subset is equivalent to choosing a subset, a k subset from 1, 2, 3, dot, 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 n plus 2 minus 2k. Okay, that's what we got over here. Choosing a k Spacey subset is sort of same as selecting a k subset from 1, 2, dot, 3, dot, dot, n plus 2 minus 2k. That's what we have got over here. Okay, very beautiful. So what's next? So therefore, number of Spacey subsets is what? Is equal to k from 0 to n. Number of k Spacey subsets. Therefore, it's what? It's summation k from 0 to n. N plus 2 minus 2k, choose k. That's it, simple stuff. Okay? Or is it true? It should be less than n by 2, I guess. I guess so, yes. Okay, guys? Exactly. The combinatorial, the previous one was also combinatorial way of doing this, but essentially it's another combinatorial way of doing this, okay? There is a beautiful reason behind it. Can someone find it out what it is? Anyways, it's a little bit homework. It's actually based on some identity, okay? Anyways, so yeah. Did you understand this, guys? Did you understand this, guys? Did you understand this, guys? Any doubts in your mind? Any single doubt in your mind? Should be n upper ceiling of n by 2. Okay, that's the upper ceiling of n by 2. So here it will be what? Summation of k to 0. Then is here what? N is 12. So it's 6. N 6 plus 8 minus 2k by k. Therefore, you see that it shouldn't be 6 over here. Should it be? No, n must be equal to 12 here. I'm so sorry. Stupid. It's 14. K must be equal to 6. Yes. Or k must be equal to 7. 7 must be 7, 7, 7, and minus k minus 1. So k minus 1 must be less than equal to upper ceiling of n by 2 plus 1, I guess. Instead of 7. So it will be sort of what? Wait. There's a sort of thing over here. Just let me check. So n plus 2 minus 2k must be greater than equal to k, otherwise it will not work, right? So that's why we are getting that n plus 2 must be greater than equal to 3k. So therefore it will be n plus 2 by 3 box upper ceiling. N plus 2 by 3. So here it's sort of 14 by 3. That is what? 14 by 3 means what? That is 5. So it's sort of 5, I think. So for this, it's sort of 5. No, it's sort of 4 here. So you see, it can be only going to 4. No, not more. Therefore, it start with 6, choose 4 result. Okay. So therefore, it's summation k from 0 to box of n plus 2 by 3. Okay. N plus 2 minus 2k by k. That is the result. See, I've solved a general problem for you. Okay, guys. So any doubts in your mind regarding this? Did you understand everything about this? This is not variant more identity. You are close. You understand everything about this, guys? Any doubts? Any doubts, guys? Question 3. So no, I mean it's a 1 hour class, so we cannot go beyond 1 hour. That's we will do the question 3 next class maybe. Let's see question 3 and question 4. Okay, guys. So uh how ceiling? Because not ceiling, because observe that n plus 2 minus 2k must be greater than or equal to k, right? Otherwise it will not happen. This will not be a, it's m choose n must be less than or equal to m. Therefore what we'll get? So therefore n plus 2 must be greater than or equal to 3k. Therefore n plus k must be less than or equal to this. Okay. Yep. Okay, so very good. So combinatorics and recursion books is there's a lot of interesting books over there. Okay, one is the art of counting, how to count, very beautiful books. Okay, and other really serious stuff is Richard Brualdi for combinatorics. Pre-college is very basic books to start. So a lot of beautiful books over here. Okay, and yeah, Richard Brualdi you can start for advanced stuff. Okay, guys, it was really nice talking to you. Very good night to you, and see you in the next class with beautiful problems and much more enjoyment. The problems are really interesting. There's an identity, Ganesh. Okay, so it's like, I mean, you have to understand what is really happening over here. Sure, you can take down question 3. I will show you. Just take it down. Take it down. Take a screenshot of it, guys. I'll give you 10 seconds. Okay, guys. Okay, bye bye. See, take our parent Kokin. Please take the problem. Please take a screenshot of it, guys. Please take a screenshot of it. Please take a screenshot of it. Okay. You can just type the screenshot. Why you can't take a screenshot? Bye bye. See you guys next class. Good night.